So next talk is entitled UAV Compliance Checking using ASP and Minimum Explanations Towards Compliance. The talk is given by Sarat Chandra Varanasi.
Yep.
Please start.
Yeah, thank you for introduction. So this is joint work with my colleagues at GE Research. And this was probably done during an internship, and then the work was extended. So the first part of this work is we have done the presentations at Lobster, I guess. And so we made some extensions and now put it in PADL. But still, this is an application paper. So this whole UAV business is, so of course, we're not programming drones or anything like that. But when it comes to the compliance space of these unmanned aerial vehicles, so there's what is known as this AMA safety code, Academy of Model Aeronautics or Aircrafts, right? So they basically regulate the space for recreational UAV flying. So if someone wants to fly their drone, they probably do need to do a pre-flight check, and all those compliance rules are written in English. It's a huge document, and we modeled for a specific chapter just to see if we can capture it in ASP, and so that will facilitate an unambiguous pre-flight checking process for anyone who wants to fly the recreational UAVs, and make that process less laborious. And so someone who is self-regulating, if they find that hey, there is some non-compliance, and there's a tool that basically provides the minimal explanations to progress towards compliance. That's the whole idea. And our contribution is we've captured all this in ASP again, and there's a front-end application that basically takes in a questionnaire. What are the input conditions that are, that will check the compliance process, and use this CASP will check the models, and it will also flag violations and provide justifications. As mentioned, that goal-directed ASP execution provides these justifications. So if there's a violation, someone can actually see the justification for where there is a violation. And then it provides a set of conditions that need to be flipped from the original questionnaire in order to progress towards compliance. And of course, the use of ASP is completely transparent to the user of this front end. And the AMA safety code looks as follows. It's basically a bunch of rules. I will not fly this model aircraft in a certain fashion. I will not be intoxicated. I'll yield right of way to all ongoing traffic, and so on. And each of the notions within these English document, we can map it to propositions. I hope it's legible at the back. So each of these bullets or these points is basically a potential for violation. So violation 1 states that, okay, hey, I will not fly it in a careless and reckless. Careless can be expanded with its own definition. So I'll use rule 7 or violation, or potential for violation of rule 7, which states that if the aircraft weighs above 55 pounds, then it needs to go through the AMA large certified program. And again, the propositions associated with this is we have an aircraft that's greater than 55 pounds, that weighs 55 pounds. And there is a violation if it's not, again, negation by failure, which is commonplace in ASP, certified by AMA large program. And the front end looks as follows: bunch of yes or no questions. So I'll also show this front end after I complete my talk. So it's a bunch of yes or no questions because everything is a proposition. And it says, okay, hey, does my aircraft weigh above 55 pounds? And in case, then there will be an additional question. And if, say, the user says no, then there is a violation. And this violation is again computed in the back end of sorts by the goal-directed solver, and say it will flag this violation and it will say, hey, the aircraft, so these are the conditions, this is the violation. And if the person clicks on how can I be compliant, The system does this minimal explanation computation, and it says that it will try to retain as many as input responses, and then it will find the difference and say that, hey, you should actually go through this certification program. And this is like, from a software engineering standpoint, front end, there is a questionnaire, the responses are fed to the Swish CASP server. So Swish is the Jan Willimakers port of CASP. So it's quite nice. I'm sure you guys have used Swish Prolog, Swish notebooks, and so on. And it also has a backend service, and it gives us back the answer sets and justification tree. So we render it on the front end, and then once we say how can I be compliant, we again perform the process of abduction, and we send a bunch of abducibles back to the Swish server, and it gives us back certain answer sets, which we will do a difference and then show the conditions that need to be changed. So again, it's a straightforward process. So guess every possible condition from the questionnaire, and that is our abducible. So all these propositions, so whether the flyer of the aircraft is using a spotter or not, and a lot of these jargon are specific to these UAV flights, and we collect all these abducibles and then send it to the Swish server, and it will give us back. And essentially, what we are asking the CASP system at the back end is, we are querying for not a violation, or bring all compliant models, and then we do a difference between the offending model and the compliant model. Right, a simple iterative procedure. So we start with a violating rule, certain rule, and partial models, again, these are specific to the goal directed execution. So the trace of literals that are proved for a query, those are the partial models, and they belong to some of so pi is basically our AMR rules. And we ask, how can there not be a violation of I or compliance of I? And it brings us back, so while doing this computation, we basically add all the abducibles, and we collect these models and find the model with where the difference is smallest. Right. So there are some limitations to using propositional ASP, because if we do everything in an yes or no fashion, we naturally lose expressivity. And few things such as a weight of an aircraft being greater than or less than a certain number, it's naturally expressed as predicate literal. So it would be natural for us to actually model the AMR rule violation in this format, as opposed to a yes or no propositional world, right? So the advantage of this is, because the CASP system has support for CLPR, when we ask it for the negation, there has to be a W here in the head. So it will produce us two models, and it will naturally do the CLPR solving for us, and it will say there is one compliant model where W needs to be less than or equal to 55, and there's another compliant model where it's greater than 55, and it goes through this AMR large program. And if we use these predicates, it's natural. Providing the explanations in terms of these constraints is much more natural than sticking to propositions. And in order to facilitate this, just like using the hash abducible for AMR large and use spotter, for propositional literals, this is very straightforward. Whereas for predicates, there is no direct support, so we'll have to artificially introduce even loops as follows. So this is again the classical even loop we use all over and over again in ASP. And for every every predicate literal that can be part of a questionnaire, so we use this pattern. And there's a slight rewrite of the violation rule. So I could write the violation as follows. So the original rule, I can extend it to predicates and ask its negation. But so if we look at this rule from violation : weight of W, W is existentially quantified. And doing the dual for existentially quantified variables is a bit complicated in goal-directed ASP. So we push this body variable onto the head and then ask, instead of not violation, I ask it not of W, violation of W. And this directly gives me the model that I was showing before. So it'll directly, this will neatly show me, give us these, it'll solve and give us these constraints, as opposed to running violation over here. Right, and the new algorithm specifically deals with those rules that have predicates within them, artificially forces the even loop, and then performs a rewrite of those rules that have predicate literals within them. And the rest of the procedure is just the same, just that for rules that have predicates, we move the body variables into the head and then do not violation of over X bar. Right, and on the Swish server, say for example, if we ask this, so violation 7 is modeled like this, and if I ask it, so it produces these, this is the model, yeah, these are the two models, and the justification trees are not shown. Right, the first model is W less than or equal to 55. The second one, W greater than 55, and it says that it is certified through the AML arch. So I'll briefly demo this. So for the demo, we just have the propositional version implemented. The predicate version needs implementation. Let me go ahead find my. I think there is time, right? Okay. I see a different time actually. I see. That's the timer. No. Okay. Try to find that. Yeah, just bear with me. I lost the folder where. Okay, great. Doesn't matter. Okay. Okay, I don't have the. Let me see from my command history. Give me a moment, please bear with me. So I must say that this application is quite simple for the logic community, but for in the space of this UAV regulation, no one has done this. Okay. How do I connect to the internet? Can you?
Can use go down a bit. There should be something with fast. Keep going down. Going down.
Okay, thank you.
it should give you a pop-up.
I think I connected to it.
Yeah, try going somewhere, it will redirect you. Oh, okay, it just works.
Yeah, thank you. To get this path. Docker desktop. Exec. Yeah, so any questions you can ask me. So this is, yeah, it's just a small. No, I mean, the talk is done. Let me actually conclude it, right? So there's a whole body of related work. So capturing English in rules is not entirely new. So one of our prior lab members, they have captured American cardiologists' congestive heart failure treatment and built it as a system called the Chef system. So it does better than cardiologists. And then there's textual rule log. It's probably Benjamin Grossoff's group or company. So they use XSB Prolog. They can map predicates to English, do explanations, provide justifications, but they're based on the well-founded semantics. We are ASP. That's the difference. And it's basically how negation is treated in well-founded versus answer set programming. So we posit that ASP is probably more robust when handling negation by failure semantics. And let me jump to the slide. So future work would be map the whole safety code. We've just taken a snippet of it and showcased it. And this is for recreational UAVs. So we need to move to the commercial space, handle more serious, guidelines such as the FAA's guidelines for, say, small UAVs. And this apparently right now it takes 90 days process to do the whole compliance process, and this can automate it and make it much faster. That's my talk. So please feel free to ask questions.
So, do you finish your talk now?
Yeah.
Okay. Thank you very much. So we have much time for Q&A. So any questions? So I have a question.
Yeah.
But for me, this is first time to know the SCASP. I'm interested in the efficiency and the scalability of your approach, especially for the SCASP. It is based on the constraint logic programming system?
Not quite, but it borrows the CLPR solver. So we start off with a query, right? Maybe I can show that at least. So there's some program, right? So we can, for example, write predicates just like logic programs, right? And we can throw in a negation as well. And say, let me build some facts. And we can run it in query interactive mode. Right, so if I ask it P of XA, it does a Prolog style unification, top-down execution,
Okay.
and returns bindings while being consistent with ASP semantics. So that's the gist of it. And because we have this unification, disunification done, we can also do CLPR.
Okay.
That's the idea.
Okay.
And scalability wise, so it's still so the grounding based and goal directed, you'd see complementary. No one solution is better than the other right now. So it's still, so we can still write programs, say for example, some of the incremental grounding and say planning problems that is hard for goal directed execution right now.
Okay.
But say some real cyber physical systems using event calculus that has dense real value time and so on,
Okay.
we can do that.
Okay. So you mean that so SCST are to use list structure like Prolog?
Yes, lists are supported.
Okay.
But
But we need to specify the query in the program, in
Yeah.
the in encoding.
That's right. It always starts with a query.
Okay. Thank you.
So there are some, we have support for list data structure as well, function symbols and so on.
Okay.
So, but it's still,
The difference between the SASP and SCASP means that just the difference constraint, right? The backend solver is different.
you mean the traditional ASP?
The SCASP can handle the constraint, right?
Yes.
Because it's based on the constraint logic programming system. No?
Yeah, not exactly constraint logic, but we brought constraint logic programming into ASP.
Okay.
Yeah.
Thank you. Any other questions?
I have a question about the safety code. So right now, how much of the safety code is encoded, and do you foresee any difficulties in coding the rest of it?
No, so we don't foresee difficulties, just that the man hours that needs to be put into it. It's just that work that was done during an internship. So it's only a chapter of it. But one could spend more time and do the rules. For example, the American cardiologist rules, I think it's an 80-page document. And so a PhD student went through it laboriously and did the translation.
Okay. Other questions?
So what does your so at the very start you mentioned that like you have aircraft that if it's too big it needs to have a certain like certification, or you need to have a certification that you're allowed to fly it. And so if you were to put in that aircraft and ask like, is this allowed to fly, it would say it failed because you need the certification. What happens if there's like more than one possible way to resolve the issue? For that example, you could say, for example, you need the certification, or you could potentially like cut off half the aircraft, and that would technically be a solution.
Yes. So, well, what we can do is put out all the possibilities.
Okay.
And let the user, because there's some ground truths that we cannot change.
Right. Yes. Okay. Thank you.
So other questions? Okay. So thank you for the speaker.
Yeah.